Hello SGD Sacred Geometry Decoded. Before I put out the Geometrology part 2, sort of the Sun, Earth and Moon stuff, where I look at, well, I thought while I was looking at old folders, I come across this one, part of a very long playlist looking at all geometry, music, astronomy, arithmetic connections via the pyramid. So not just individually, but how they all connect together. I'll try to remember to put the link to that video in there as well, because the proportions of the individual pyramids at Giza also give you the proportions that will link to other pyramids, such as the Red Pyramid and the Bent Pyramid. Basically 2 to 3 and 5 to 8, that's their Fibonacci numbers, 2 and 3, 5 and 8, and 7, 11, which is their Lucas numbers or Lucar numbers. But they describe not the individual pyramids, but how there's a very lovely, the proportions of individual pyramids will give you the link to other pyramids. But the point of this video will be, because I was talking about that geometrology and Sun, Earth and Moon and astronomical connections. So that's what this one will be on now. Next to the Red Pyramid was found this, well, they call it a capstone, but because it has a different angle to the Red Pyramid, I doubt very much it would be a capstone to the Red Pyramid, but it is an important feature for a number of reasons. But ERC, or Egyptian Royal Cubits, so the Great Pyramid, Pyramid of Khufu, 440 Egyptian Royal Cubits wide and 280 Egyptian Royal Cubits high. You can reduce that to a 11 wide by 7 high ratio. The Maidum Pyramid, although it's largely collapsed, there are still enough so we can measure the base survives, and there's enough of a slope there at the bottom to measure the angle, so we can, even though it's largely collapsed, we can still get the height, and that gives it a 275 Egyptian Royal Cubits wide by 175 Egyptian Royal Cubits high. We can reduce that to an 11 by 7 high ratio, just like the Great Pyramid. Next to the Red Pyramid was found that pyramidion or capstone. There you can see what happened to it around about 2010, but before that, when it was found and put back together, we had it was 1 meter high, and the base was 3 Egyptian Royal Cubits, or pi over 2 meters, which gives it a 7 high to 11 wide proportion. So that Great Pyramid, and as a right angle triangle, 14 to 11. And so all of those, this is the Great Pyramid, but we can see now, for instance, if the half, so 14 high by 11, and from there we can get the slopes, and just let me deal with this pling. So 14 high by 11 wide, so if the half base is 1, then the slope would be 1.61859034. Essentially, that's the golden number, phi. And just because of the rules of right angle triangles, that's the square root of phi. Now I'm using idealized measures because, for instance, the Great Pyramid, the north side is 20 centimeters shorter than the south side, which is the longest. North is the shortest, south side is the longest. So there are little variations in there, and if you include those, you'll get this very good approximate of the golden number, comes essentially to 99.999%, and so we get the square root of it as well. Now, and that angle is based on the idealized, again, it's ever so slight variations. Now, where there is matter, there is geometry by Kepler. So here's one version, so we see just the proportions, but if you look at it this way now, for instance, if the height of the pyramid is 4, then the half base is pi, or very, very close to it. If the half base is 1, then the height is the square root of phi, and the slope is phi, or again, very, very close to it. Again, remember there are slight variations. In that longer series I went through it in more detail, and you're getting well above construction levels anyway. So a Kepler triangle, which is a perfect phi, so If the hypotenuse is phi, then that edge has to be the square root of phi, and the base is 1. Now, a perfect Kepler triangle is 51.827 etc. degrees. The Great Pyramid 711 angle is 51.84. And you see, just a tiny fraction of a degree is all that you need to find as. Now, what they call the 4 problems of antiquity: doubling the cube, construct a cube whose volume is double that of a given one. Well, the volume of the inside of the sarcophagus in the Great Pyramid is half the volume of the outside of in there. But these are now angle trisection. That one's a tricky one. Squaring a circle and constructing a regular heptagon. So a 7-sided polygon or a 7-pointed star. How do you draw that with compass and straight edge geometry? Well, the angle is 51.4 degrees. So if you were to, now, you cannot construct that with compass and straight edge. That's like one of these it's been proven with more modern math techniques, but you can make very accurate approximates, and it's not the best approximate. There are other ways to do it, but 51.4 degrees is, again, very, very close to this. So the Great Pyramid in itself is a good way to draw a 7-pointed star. And now squaring a circle. Now that's another one. So along with doubling the cube and constructing a regular heptagon, which we could get very, very good approximates by what's in the Great Pyramid. Let's look at squaring a circle. And it's to construct a circle whose area is equal to that of a given circle. Now that's the proper squaring a circle. Now, even to square a circle, you might have heard the phrase squaring the circle. How do we square this? So it's essentially, it's a phrase to do with unsolvable problems, because that's what it is with compass and straight edge, at least. However, if we want to construct a circle, so pure squaring a circle is about the area. The area of a circle should be equal to the area of a square. But a variation on this is to construct a circle whose circumference is equal to the perimeter of a square. And there we see the 11 wide by 7 high triangle of the Great Pyramid, 11 by 7. And so if we use that as the basis, we can square a circle in terms of circumference to perimeter. Now, because of the transcendental nature of pi, we'll never quite get it, but we can do, again, a very, very good approximate. And I'm showing this because this geometries also relate to astronomy, sun, earth, moon, and planets. So the base of a pyramid is 11, therefore the edge length of the square is 11, therefore the perimeter of a square is 44, and the 11, now therefore the radius of the circle would be 7, or in other words, diameter of 14. And so the circumference of the circle, if it's 14, then if the diameter is 14, then the circumference of a circle will be 43.98229, etc. Again, very close approximate. I'll show this is the J.H. Cole survey, which includes the Petrie survey. Later surveys have confirmed this. We're just talking slivers. Even the most modern surveys, everyone gets a slightly different opinion because exactly where the corner is. But what we have is that the pyramid is actually not a square base. Now that's highly exaggerated, but it's a trapezoid. The north side is 755.4 feet. The south side, the longest, is 756.08 or 7. Now that will account for those variations in there, but we can go forward. So if you include the variations, but now we come back to this geometry. Others have pointed, for instance, this can be noted in Stonehenge and many other ancient sites as well. Apparently unconnected. So another way to think about that, so here I have the 14 by 11. So what we have is 14 in total, or 11 plus 3. And keep that in mind. Now, that geometry gives us a relative size of the Earth in regards to the Moon. This is one way I like this drawing because they're sort of both enclosed. But another way to look at it is like this. So if the Earth is inside the square, then the circle gives you the radius of the moon, cuts the moon in two. So we get the relative size of Earth and moon from this geometry. And now we come back to the Caffrey pyramid. It's 411 cubits wide at the base, 274 high, which gives it 3 wide to 2 high. And so the right angle triangle inside Caffrey's pyramid is 3, 4, 5, the first of the Pythagorean triplets, a squared plus b squared equals c squared. Now if we cut that in half, you can see that that fits perfectly within this geometry as well. And we'll keep that in mind. So we already got the Earth and the moon and this pi, phi squaring the circle in regards to perimeters and circumference. I mentioned before, so 11, if 11 is 1, then 3 is 0.272727. The moon is 27.3% the size of the Earth, but so that's 27.3% in essence. And again, if you include the variations in the pyramid, for instance, the northwest corner has this it's just essentially perfect. If you include the variations, northwest corner is the astronomy corner, I say. So while we're talking over the Earth, the moon orbits the Earth. Now, what the moon doesn't orbit the Earth at the core because they both have weight and they're pulling and tugging on one another. So what happens is that the moon orbits the Earth at what's something that's called the barycenter, which is 27.3% below the Earth's surface. So again, we have this 11 to 3 ratio, which again we find here. So 11, so I've written 14 here, that's the total, but it's 11. The Earth is 11 and the moon is 3. So again, just a different way of viewing it. But because of the elliptical nature of things, sometimes a little bit further away, sometimes the moon's a little bit closer. And so there's nice connections here in regards to the barycenter. So it's hovering around 1,000 miles below the Earth's surface, but it is moving back and forth during perigee and apogee. And the diameter of the moon is 2,160 miles, so the radius of the moon is 1,080 miles. So the radius of the moon also cut the moon in half, and that describes how far below the Earth's surface the moon is orbiting the Earth. And 1,005 miles is phi precisely times 1,000 kilometers. So it is passing through all of these points within the elliptical nature of things. Now, geometry is about perfect squares and lines, but nature is about elasticity and with slight variations in there. And just like the pyramid has slight variations, I just think it's an interesting concept. So we come back to the pyramids, the 7-11, and we've already, like pi and phi, a good way of approximating squaring the circle in regards to perimeter and circumference, not area, of course. So, and the barycenter as well. So get a bit of information. Geometry and astronomy emerging together. Geometry, geo is Earth, as in Gaia, Earth, and metry, as in meter, is measurement. Ancient Greek words. Metron. Gaia is now, Gaia in Greek is geo. Metron is metry, measure. Well, that's where the meter comes from. So when we look, this is across all esoteric symbolism, what you'll always see is the sun, the moon, the earth, and the stars. And so, for instance, in this tracing board, we have the sun, we have the moon, we have the two columns, and there's always the terrestrial sphere, the earth, and the celestial sphere, the stars. Sun, earth, moon, and stars. Okay, geometry. Now the quadrivium, music, arithmetic, geometry, and astronomy. So back to the Great Caffrey and Menkaure pyramid. Great Pyramid, 440 by 280 Egyptian royal cubits high. That's at 711 proportion. Caffrey Pyramid, 411 cubits wide, 274 high. That gives us the 2 to 3 ratio, which gives us a 3, 4, 5 triangle, and the Vesica Pisces. So to draw the Caffrey pyramid, just draw a Vesica, enclose it in a rectangle. You'll get the 3, 4, 5 triangle. And also, for instance, in stonemasons, I'm showing a Freemasons here, but 3, 4, 5 triangle symbolism. But an application is just for all sorts of things, but especially the old school stonemasons, the builders of the temple. Now, Menkaure pyramid. The east and west side's a little bit shorter, but north and south, 200 Egyptian raw cubits wide by 125 Egyptian raw cubits high, so it's 8 wide to 5 high, or 1.6 to 1. Now, the Caffrey pyramid, I mentioned that's 2 to 3 ratio. That's a Fibonacci sequence, and 5 and 8 are also Fibonacci sequences as well. So again, if you draw a Fibonacci spiral, we have an 8 to 5 rectangle, that's the Menkaure pyramid, and a 2 to 3 gives us the Caffrey pyramid. Now let's look at the pyramids and the planets. Geometry, Earth measure. We've already got the relative sizes of the Earth and the Moon emerging from the Vesica, and that 3, 4, 5 triangle flipping. Was it Heath or Michelle who come up with this diagram? This is not my these diagrams are I forget, one of those other metrologists. So, but let's look at it in a different way. So the diameter of the Earth, 7,920 miles. Because of the oblate spheroid thing, but I'm slightly rounding it off there, but it's 99.99% precise. And so if you do, like, you could Google it, and you'd probably get 7,921 as the diameter, equatorial diameter. But then in comes the issue. So 1 mile here or there, firstly over 7,920 is infinitesimally small. But if I was to measure the Earth at this point, I would have a high, where Africa's there, that would make it a little bit larger than if I was to measure on the other side when I was on water and there was no mountains. So there's the issue of how you measure and when you measure in these types of things as well. So especially when you see any planetary Earth diameter circumference measure, it's almost like the coastline paradox. There are not exactly the same, but it's like it depends on how you do it and at what point you do it as well. So just in case you look up 7,920, you don't get that exactly. Well, there are agreed values, but again, if you measure if I was to take that snapshot when the mountains are on one side, as opposed to wait a little bit till the water was on the other side, we'd get that 1 mile difference would disappear. Okay, don't need those ones. Okay, now the Moon doesn't orbit the Earth, as I pointed out. The Moon's around the barycenter. That's when you do that square and circle diagram based on the Great Pyramid. It's also interesting that that marks the point where the barycenter is 27.3% below the Earth's surface. The Moon is 27.3% the size of the Earth. So by drawing the Moon inside there, the radius would define where the barycenter is. And so again, it's just a matter of just using the same diagram. You just rearrange it as it fits inside, and based on just that square and circle, it all comes together. So it's also be interesting to note that the barycenter is 2,880 miles below the surface. I've got some videos on 288 and just how it pops up everywhere. Okay, now again, elliptical nature of things. Okay, I already mentioned before that the barycenter will pass through precisely 5 times 1,000 kilometers amongst those other points as well. And again, that would that's the half base to the slope of the pyramid. Now, same geometry of the pyramids also joins Sun, Mercury, Venus, Earth, Moon and Mars in an extraordinary series of coincidence. God's of astronomy, weights and measure back in the day. Also, you know, we've always got the symbols. So we've Vesica Pisces, 2 to 3, Caffrey pyramid, 3, 4, 5 triangle. All right, now it's back to that 14 and 11. Now let's use the Vesica. So I just got Caffrey's pyramid and the Vesica. Now we have 14, 11 and 8, and then 5, and notice also 8 and 5, that's proportions of the Menkaure pyramid, which just reverse engineering from the pyramid, Great Pyramid, by the 2 to 3 ratio of Caffrey pyramid, you get those features in there. Now we have 2, 5, 8 and 11. No, they're separated by 3, 2 and 3, Vesica, okay. So we have 2 and 3, 8 and 5, Fibonacci numbers. As we saw, you draw a Fibonacci spiral and you get the Caffrey and the Menkaure pyramid. Now the 3, 4, 5 triangle, so if you were to draw that emerges from so the Lucas spiral emerges from the same thing. Okay, now Faucheset, architecture, astronomy, so like the gods of ancient science, let's call it. Now we come back to now the Earth. So we already saw in that diagram we get the relative size of the Earth and the Moon, and the Earth diameter would be 11 and the Moon diameter would be 3, 14 minus 11. So we're using Earth, so Earth is 1, very much like Bode's law, and even 1 astronomical unit is the average distance from the Sun to the Earth. All right, so we have our ruler, so there are our points. So that's 11, which is the Earth, would mark as 1, and there we can see the proportions, what they would be in numerical. All right, so the Sun and 1 astronomical unit, AU, average distance from the Sun to the Earth. So we're using that as our measure, and in the next part of that geometrology one, I'll put the link in. Already was talking about like Bode's law and this inherent geometry puts Earth in that, makes Earth 1. Bode's law, Vesica Pi, you can, yeah, I'll try to remember to put that link in. So Bode's law defines the distance from the Sun to the Earth as 1. Again, we're just using that same geometry. Now, just so happens that Venus would be at 8. So Venus would fall right on that spot, and Mercury would fall on that spot as well. I won't go into, there is a little bit of a tiny sliver of a fraction of a discrepancy in Venus. Venus sits like, just touches the edge of that belt, but it will mark. So again, when I cover Bode's law more, and if you look up the Bode's law videos, and but again, Venus is the only planet which rotates in the opposite direction. Most say probably because there was some sort of great, there was an impact, something happened to Venus in the past to make it behave completely different to all. It does orbit the Sun in the same direction as all the other planets, but it rotates in the opposite direction, that the Sun rises in the west and sets in the east, unlike everywhere else. Now it's all sort of built, again, go back to that 27.3 or 0.27272. Now in regards to AU, the Moon is 0.00273 AU from the Earth. And this is an older video, and the one that will be coming up next, I'll go into other connections to the cubit and stuff, but just before I finish that off, I thought I'd go through this one again, because it was in a very long playlist, and it was sort of broken up into a few pieces as well. Now we come back to the Menkaure pyramid, which has this 8 to 5, or depends how you view it, 5 to 8 ratio, or 1.6 wide to 1 high. So you can use 1 to 1.6. Again, just like the golden number phi from the pyramid. And so let's put that, insert that there. Now that would mark out the position of Mars from the Earth. So if the position of Mars from the Sun. If the Earth is 1, then Mars passes through 1.6 or phi AU. And we get the geometry. So Great Pyramid is a model of the Earth. I'll just flash through this one again. Anyway, it depends on how, if you view the pyramid as a pyramid, not as a triangle and a square base, what you'll find is that the pyramid at 86,400 to 1, as in number of seconds per day, will give you the size of the Earth, including your oblate spheroid polar diameter, a touch smaller than the equatorial diameter. And if you view the pyramid at the corner and view it as a pyramid, all that information is there. But I'll maybe try to remember to drop that link in there. But anyway, number, geometry, Sun, Earth, Moon, and planets, and that 1 second, 86,400 seconds per day, relates to the 1 meter pendulum, which describes the ancient Egyptian royal cubit as well. That's, before I do the next one, I thought I'd just drop this one in here as a bit of a reminder, because I'm going to be showing this, but in a again, much more elegant sort of fashion, and linking a lot of things just with this really simple Euclidean geometry and known units of measure that have existed and their relationship between them. It's a, call it a symphony of coincidence, if you will, but it is, at the very least, it's a mnemonic memory tool, a way of learning. And so again, I think a lot of people, especially in their youth, would, instead of learning everything separate, just like the quadrivium, if we were taught geometry while we studied music, and if we were taught music while we studied arithmetic, we'd be a lot better off, rather than having all these things separated. I think it's about connections as well. So whether they knew about this in the past, that can be argued. There's no way I know how to prove it. There is no existing texts that say that they do. But that doesn't really take away from the fact that it does exist, whether it was intentional or not, whether it was just a whole symphony of beautiful coincidence, who's to say? But it is there. By design or by chance, it is there. Alright, so that's it. Just thought I'd throw this project out before I bring up the next one, because the meter, the yard, the cubit, the 1 second division of time, and how Sun, Earth, Moon, and planets come together, and we can find a way. We can fix the errors in regards to Venus and its distance from there, and the geometric connections that run through these things. All right, so that's it. If you've been following for a while, you might have seen this. I went through it very, very, very quickly, but essentially you can use this geometry of the pyramids and a lot of this ancient architecture, very simple geometry, to describe a whole lot of things. And whether it's coincidence or not, I don't think it really even matters. At least as a teaching tool, if I had learned this the way I've discovered it in my later age, I would not have been bored witless in most classes at school. Because I think if it was I had good teachers and they made learning really exciting, but I had bad teachers and they made it miserable. But even a bad teacher who was teaching it in a good way, such as this, I think would make it interesting. And what better thing to learn things in your youth. Anyway, with that, SGD. Cheers.